Oh, yeah. Wait. Oh, I think it's 169. Yeah.
Change it.
For 15 you get? No.
Thank you.
Yeah, no.
It's like filled with maybe.
Then this is, okay.
Maybe.
Thank you. I love your color. I
Nobody else got it.
Realized I didn't wear Valentine's Day drinks. It's like the only day you can wear it. That's all I wore is Valentine's. I don't own anything red cake. Very festive. Oh, thank you. I like threw this together. I literally woke up really late and then I got here late and it was not good. Well, I didn't get here late, but I had to like hurry here. And I just was like, yeah, I'll put this on. I'm in the spirit for Valentine's Day. Can you tell? Black. You're wearing
No, I never celebrated that. That's just like, that's so nerdy. I still think it is. But it's a good way to force people to give you chocolates. Exactly.
My
Your
mom
boyfriend
didn't
gonna
give
be
me anything today.
Huh? Your boyfriend? Well, of course he is. Well, if he doesn't, he's grounded.
He's grounded. What, is he your child now?
You know, sometimes you have to be a baby, so I feel like a baby. Huh?
Are you suggesting that you would date your child?
No.
I'm just kidding.
Oh boy.
That'd be weird.
I'm just kidding, guys. Come on.
I mean,
Use your brains.
who did that though? Was it Woody Allen?
Yeah, Woody Allen, he dated his daughter. I know he's married to his daughter.
Yeah.
His stepdaughter or something.
Yeah.
Isn't Woody Allen married to his
Yep.
stepdaughter?
I don't know. He like had his wife and then adopted a baby. She like grew up to be like 17 or whatever. And he's like, you know what? I think I will marry you.
Yeah, isn't that weird? Ugh.
Yeah.
And she had said she's adopted. I guess she's technically
Yeah, but if you like
not
raise,
your biological daughter.
raise them.
Ugh, that's weird. Ugh. I mean, when I was little, I used to say I wanted to marry my dad, but
Well,
not
everybody
actually.
does.
Yeah.
Well, there's that saying. It's like, oh, you want to say that?
Yeah. Not anymore.
All right. So on your homework assignment, I sort of jumped the gun in assigning you that because we hadn't actually talked about displacement yet, and we had only talked about velocities, and I didn't realize it until I started looking at it. And after you asked me, Lauren, you were like, "This doesn't look like a curve." Well, yeah, because we were talking about the velocity and not the displacement. So I'm very sorry about that, but we're going to talk about the displacement today, and then I'll help you fix your worksheets. Some of them were about what we were talking about yesterday, but some of them were not. So let's first review what we're
Explain number 2, no, number 4, because I couldn't get it to like line up.
Well, it's because we haven't talked about it yet,
Okay.
so I apologize, that was my bad. But let's review what we did talk about yesterday with the multiple choice questions. So the diagram below shows the velocity components for a projectile at location x. Which diagram on the right shows the correct velocity components at location Y?
I don't
It's
quite
A.
understand.
A.
That's correct. So, at location Y, that's at the time 0, basically, the horizontal component will be the same as for X, because the horizontal velocities remain constant, right? So A is the only one that has the same horizontal component that X does in that case. So here's another one. Which diagram shows the correct velocity at location Y?
B.
Why do you say B?
Because the, like, in our pictures, there's always like longer, like more space between it as it goes, so I figured longer arrow. More.
Right, that's correct. So the horizontal vector stays the same. The vertical is longer because it's accelerating, right? The acceleration of gravity, so it's going farther as it drops. Okay, match the v sub x and v sub y components at the proper location in the trajectory diagram. One option does not match. So this is going to be very difficult for you to tell me, but
It's the first one, like the last one on the right.
okay.
The second one to the last one on the left. That makes sense. The one that has like no.
This one?
No,
it doesn't.
the
No.
next. The how do I just
This
okay,
one?
yeah, that one. No, that's right.
I was gonna go for the middle.
I don't
Is the
know.
down arrow
I'm
gonna be in
not
the
sure.
middle?
I just see a bunch of
No?
arrows.
Okay.
Maybe.
For which one's gonna go in the trash?
The one
The one with
the one that's like has like a short arrow. and
The
not
first
arrow.
one?
No.
The third one. Cause the horizontal doesn't look the same.
I think
the
we're all.
horizontal. I think the third one
Lazy.
because it's too long of an arrow up. Oh, I don't know.
I'm so confused.
I just see
Or maybe
arrows.
it's the horizontal arrow at the beginning that I don't get.
Okay. Alright, let's think about, first of all, our horizontal components. What do we know about the horizontal components?
Space.
They should all be the same. So which one has a different horizontal component?
Third one.
Same.
Nope. Never mind. The last.
This one doesn't have a horizontal component at all, so that's trash. Okay. When we originally launched the ball into the air, what do you think the vertical component would be? Longer, shorter? Right now we're saying it's nothing. When we throw it up into the air, how long, comparatively speaking, would the vertical component, the vertical velocity be?
A lot?
It would be a lot. It would be a lot. When is the vertical velocity 0?
When it's in the air. Right before it's reaching.
The one that we have right here only has a horizontal, so when,
That one.
Oh, yes.
where was that one
It's the
gonna go?
peak.
The peak, okay, good. Okay, so that will go at the peak. And when is there's two of these that have the vertical velocity going up, and one of them that has it going down. Which one is gonna be the one that's going down?
The last one.
Okay, good. So when we initially throw it into the air, is it gonna be the longer one or the shorter one?
Longer.
Yay! Okay, does that make more sense?
Yes.
Yeah. Maybe that'll be another one, maybe not. Okay, A projectile is launched horizontally with initial velocity of 12. Which set of numbers describe the numerical velocity, numerical value of the horizontal velocity after 1, 2, and 3 seconds? This is a horizontal.
Oh, just kidding.
Yeah.
B, because the horizontal velocity will stay the same. Alright, a projectile is launched horizontally with initial velocity of 12. Which set of numbers describe? This must be the vertical velocity. Specify that. Right, okay. A ball is thrown upward at an angle. It travels to its highest point before falling. Which statements describe the velocity at its peak? Good. The vertical velocity is 0 at the peak, and the horizontal velocity is, they didn't tell you what it was, but whatever you started with, it will be the same. 3 seconds before reaching the peak, a projectile has a v sub x value of 24 meters per second and a v sub y value of 29.4 meters per second. What are the numerical values of v sub x and v sub y 3 seconds after falling from its peak? Well, what's the v sub x going to be? 24. Okay, so that leaves us with choices C and D. So after falling 3 seconds, if the initial vertical velocity was 29.4, what would it be after 3 seconds?
Is it 29.4?
Not the vertical velocity.
It would be C.
What is it doing?
No, maybe you're right. What did it say?
Because it's, okay, it's 3 seconds before and then 3 seconds after, so it'd be like a reflection.
3 seconds after.
Puzzled.
Oh, that wasn't the initial, that was 3 seconds before. Okay. Because, yes, my bad. So they gave you the 3 seconds before. So here's the peak, this is 3 seconds before, 3 seconds after, they are going to be the same. Because it's,
Because it's a
I
parabola.
can't talk today. Yeah, they're symmetrical. Yeah, parabola. Okay, I thought that was the initial, I'm sorry. 3 seconds before, here's another one. 3 seconds before reaching the peak, it has a horizontal value of 24 and a vertical of 29.4. What are the numerical values 2 seconds after falling from its peak? So this one is 2 seconds after and they gave you 3 seconds before.
19.6 or D.
Good. How did you get that?
I just memorized
Process
from the homework
elimination.
Yeah, last night. The 19.6 comes before 20.
Okay. 3 seconds before is 24 and 29.4. What are the numerical values 1 second before?
That one's C.
Okay, good. Alright, go ahead and get out your notes and then we'll talk about my bad and your homework assignment and how we can fix it. So up to this point, we've mainly been discussing the velocity. So let's review. Velocity is like what? What is velocity?
Acceleration.
Direction, it's not acceleration though. Acceleration is separate from velocity.
Changing speed, direction and speed?
Speed, it's just it's the speed and direction, right? And what is displacement?
Distance.
Distance, right. So on your assignment, you were supposed to be graphing the distances that the balls had fallen, but we hadn't talked about distance, so you probably were graphing the velocity since that's what we've been talking about. And that's why it was a straight line and not a curved line. So these formulas should look familiar. They're very old though. It's been a long time. Back in the first unit I think that we did. So the vertical displacement, the formula that we normally use has initial velocity in it, but since the initial vertical velocity is always going to be 0, ours isn't going to have that. And then we have the acceleration of gravity times the time. I feel like that maybe is supposed to be squared. Yeah, sorry, that's time squared. And then the horizontal displacement is influenced by the initial velocity and the amount of time that it's been in motion. And so the formula is just initial velocity times time. So v sub I means initial velocity, and since it says ix, that's talking about the initial horizontal velocity. Okay, so we're going to do an example of this. So d sub x and d of y is the horizontal displacement and the vertical displacement. You just can't shake that cold can, Molly.
No. Stinks.
displacement, horizontal displacement is the second one. It's just the initial velocity times the time. So, the initial velocity horizontally is 20. So this would be, after times 0, it would be 0. After 1, it would be 20. After 2, it would be 40. 3, 4, 5, 100. Okay? For the other, you might want your calculator. So the other one is the 1/2 g times t squared. So it's still going to be 0. And then here it's going to be 1/2 times 9.8 times 1 squared. 1/2 times 9.8 times 2 squared.
Do you have to times it by negative 9.8 or just should you?
I was going to address that. Technically, the acceleration of gravity is negative because it's pulling you downward in the downward direction. Sometimes for the displacement they are going to say down, or sometimes we're going to want it to be like a negative number because if it started off maybe going in a positive. So if you want to put these numbers as negative, that would be fine, yes. It sort of depends on the problem, I guess. So after 1 second, what's the vertical displacement? 4.9. After 2 seconds, and if you want to say negative 4.9, that's fine.
I got negative 19.6.
Good.
1.8.
Okay, good. So let's take this as an opportunity to fix our homework. Since I messed you up on that. So this would be the same as for the baseball and the cannonball for the vertical displacement. So for the baseball, the vertical displacement after 1 second would be 4.9, or negative 4.9, going 4.9 meters down. And then it would be 19.6 and 44.1, and so on. And it would be the same for the cannonball, for the y component. Actually, this is for 20 as well, so this is the same numbers for the x as well. So 0, 20, 40, 60, 80, 100. That was just a coincidence that I did that, but
What number are we on?
number 1.
Oh, okay.
So where they have the baseball and the cannonball. So the baseball, the vertical displacement would be the same numbers that we just came up with.
Okay, so it's not what we did yesterday.
No, because that's
Okay.
my bad. I apologize for that. Which is why your line looks sort of like a straight line, because the velocity is changing by the same amount every time, but the displacement would be different. So then, the same vertical displacement for the cannonball, and the cannonball's horizontal displacement is the same as the horizontal displacement we just did, because it was 20 as well. The velocity was. And so if you could graph that on the graph that's provided there for the baseball and the
How do you do
cannonball. You have to do some estimating,
Oh,
but
okay.
yeah, so like 4.9 would be way up there then. Mm-hmm.
Where are we calculating the numbers?
So this is for the baseball, and you just are gonna have to do some estimating for the smaller ones, but so like 4.9 would be up here, somewhere between.
So would you,
And you just put a dot, right? This one's going straight down, so you just put a dot, just like you did, it looks like yesterday, where you thought. And then over here, it's going to be going like over 20, and then down 4.9. That looks better, doesn't it?
So for this graph, it goes over 20
And then down. Mhm.
Okay.
Which makes more sense when we go to answer the other questions by looking at the graph. What did you guys say for number 3? Which of these two strike the ground first?
I said both.
Right, that's right. They should hit the ground at the same time. Because the vertical displacement is the same. And in answer to your question about number 4, Holly, describe the effect on an object's horizontal motion upon the object's vertical motion. So, in the case of the cannon, when you combine the horizontal and the vertical motion, what shape basically is the trajectory of the cannonball when they're combined?
Half of the parameter.
Mhm.
Yeah.
So, when you combine those two motions, it creates the parabolic trajectory, or half of a parabola. What did you say, Lauren? I might not be wrong necessarily.
I put the horizontal and vertical motions are independent.
Well, that's true. That's definitely true. I'm not sure if that's what they were asking, but I'm glad that you know that that's true.
was that for number 4?
Yes.
What was that?
That when you combine the two, it forms like a parabola shape.
When combining the horizontal and vertical?
Okay, so you guys feel a little bit better about that? The other ones were okay because they, well, for number 5, they gave you the diagram, and they were asking you about displacement, which is what we're talking about today. But since they gave you the diagram with the distances, you could just look at that to determine how far it moved horizontally and how far it moved vertically. And number 6 was talking about the velocities, which is what we did yesterday. So those should be okay. What did you guys put for number 5?
250, right, and 125 to?
Good, yeah. So the x displacement was 250 to the right, and the y was 125 down.
This one.
Yes.
On what we did yesterday, will they always be positive if it's going up, and then when the ball comes back down, the negative? The
Yes.
numbers are negative, okay.
Okay. So that is for